Hello everyone. In this lecture, we are going to discuss about the topic SLR Parser in compiler design. First, let us see what is SLR Parser. SLR stands for Simple LR Grammar. It is an example of bottom-up parser. In SLR, S represents simple, and in LR, L represents the scanning of input from left to right, and R represents the construction of derivation in reverse order, and 1 here represents the number of input symbols of look ahead. Let us see the steps in constructing the SLR parser. First step is add augmented production in the given grammar. Second step is to create canonical collection of LR of 0 items. Third step is to construct the SLR parsing table. And fourth step is to parse the given string using the constructed parsing table. Let us understand the concept of SLR parser with an example. Consider the example grammar with 3 productions given here. S tends to AA, A tends to AA and A tends to B. So our first step is to create the augmented grammar. So for this we have to introduce the augmented production. So it contains the newly introduced variable which points to the start symbol. So here start symbol is S. So we can write the augmented production as S dash tends to S. So S dash is the newly introduced variable and S is the start symbol. Then we have to write all the productions in the given grammar as it is. So S tends to AA, A tends to AA and A tends to B. So thus we have created the augmented grammar. Next step is we have to create the canonical item sets. Let the initial item set be I0. So for creating the initial item set, we have to introduce the dot before the start symbol in the RHS of the augmented grammar. So here before the start symbol S, we have to place the dot. So S dash tends to dot S. So whenever a dot is there before the variable, we have to write the relevant production of that particular variable. So for S, we have one production, that is S tends to AA. While writing the productions, we have to place the dot in the RHS before the first symbol. So we can write it as S tends to dot AA. So now the dot is before the variable A. So we can write the relevant productions of A. So A is having two productions, A, that is A tends to AA and A tends to B. So we can write it as A tends to dot AA and A tends to dot B. So we have to place the dot before first symbol in the RHS for every production in the item set 0. Now we have to consider this item set, and for each production we have to consider the symbol which is having the dot before it and then expand this item set. So in the first production, dot is before the variable S. So considering I0 comma S, we have to move dot 1 position to the right. In the further item sets, we have to move dot 1 position to the right. So it can be written as S dash tends to S dot. So since the dot is at the end of the production, we cannot expand it further, and let this be new item set which is named as I1. Next, considering the second production, we have the dot before the variable A. So consider I0 comma A. So move dot 1 position to the right here. So it can be written as S tends to A dot A. So here dot is before the variable A. So we have to write the relevant productions of A. A is having two productions, that is A tends to dot AA and A tends to dot B. Now this is the new item set. Let us name it as I2. Next, consider third production here. So dot is before the terminal A. So consider I0 comma small a. Move dot 1 position to the right. So it can be written as A tends to A dot A. So A is that is the dot is before the A. So we have to write the relevant productions of A. So A is having two productions, that is A tends to dot AA and A tends to dot B. So consider this as the new item set which is named as I3. Next, finally we have to consider the fourth production. Here dot is before the terminal B. So consider I0 comma small b. Move dot 1 position to the right. Then it becomes A tends to B dot. So this is the new item set. Let it be I4. So we have completed the item set 0. Coming to the item set 1, we cannot expand it further. So we have to consider item set 2. So in the first production, we have the dot before the variable A. So consider I2 comma A. So move dot 1 position to the right in this production. So we can make it as S tends to AA dot. So dot is at the end of the production, so it is not further expandable. So let this be new item set, that is I5. Next, consider the second production in I2. So dot is before the terminal A, so consider I2 comma small a. So move the dot one position to the right, so A tends to A dot A. So dot is before A, write the relevant productions of A. So A tends to dot AA and A tends to dot B. So this item set is similar to the item set 3, which is already existing. So we should not give the new name for this item set. So consider the same name, which is I3. Next we have to consider the third production. Here dot is before the terminal B, so consider I2 comma B. So move dot one position to the right, so it becomes A tends to B dot. This is similar to item set 4, so we name it as I4. So we have completed the item set 2. Next I3. So in the first production, dot is before the variable A, so consider I3 comma A. So move dot one position to the right, so we can write it as A tends to AA dot. So dot is at the end of the production, so we cannot expand it further. So this is the new item set, so name it as I6. Next, in the second production, dot is before the small a, so consider I3 comma A. Move the dot one position to the right, so it can be written as A tends to A dot A. So dot is before the variable A, so write the relevant productions of A, that is A tends to dot AA and A tends to dot B. So this is similar to the item set 3, so we name it as I3. Next, in I3 we have to consider the third production, that is A tends to dot B. Dot is before the terminal B, so consider I3 comma B. So move dot one position to the right, so that is A tends to B dot. So this is similar to the item set 4, so name it as I4. So we have completed I3. If we consider I4, it is not further expandable because dot is at the end of the production. In the same way, I5 is not expandable, and I6 also contains the dot at the end of the production. So thus we have created the canonical item sets for the given grammar. So we can represent these canonical item sets with the state transition diagram as mentioned here. So here I0, we start with the initial item set I0. We have the relevant productions of I0 here. So I0 on S, where is the transition? I0 on S means it makes a transition to I1. So that is what mentioned here. So I0 on capital S, it goes to I1. Next, if we consider this, I0 on A, it goes to I2. I0 on A, it goes to I2. I0 on small a, it goes to I3. So I0 on small a, it goes to I3. Then I0 on B. I0 on B, it goes to I4. So I0 on B, it goes to I4. Next, I2 on A, it goes to I5. I2 on capital A goes to I5. I2 on small a goes to I3. So I2 on small a goes to I3 and I2 on small b goes to I4. So it is mentioned here I2 on small b goes to I4. Then I3 on capital A, it goes to I6. So I3 on capital A goes to I6. I3 on small a, it goes to itself, that is I3. So I3 on small a goes to I3 itself, and then I3 on small b, it goes to I4. So I3 on small b goes to I4. So thus we have represented the canonical item sets with the transition diagram. Next, let us construct the parsing table. So consider the given grammar. Let us number it as 1, 2, 3. So this is the transition diagram which is used for constructing the parsing table. So for constructing the parsing table, we need to define two functions. One is goTo and another one is action. So goTo contains all the list of non-terminals and action contains the list of terminals along with the $sign. So action can be of 4 types, that is shift, reduce, accept and error. So shift means we will be pushing the elements into the stack. Reduce means we will be popping the elements from the stack, and accept means the string is being accepted, and error means there is some error in the table. So let us construct the parsing table. So it contains 3 columns: item set, action and goTo. So in item set we represent all the item sets. We have 6 item sets from I0 to I6, so that is represented here. And in action we have list of terminals in the grammar. So in the grammar we have 2 terminals A and B. Apart from that we have to include $sign also, which is necessary for parsing the input string. And in goTo we need to consider the non-terminals in the grammar. So we have 2 non-terminals, that is A and S, so that is represented here. Always 1 comma dollar, item set 1 and dollar will be accept state. So next we have to consider the state transition diagram and construct the shift operations. So here I0 on S, I0 on S, it goes to the I1. So near the row I0 on column capital S, we have to mention the item set number. So what is the item set number? It is I1. So we have to consider only the number 1. Next, I0 on capital A, it makes a transition to I2. So I0 on the row I0 on column A, we have to represent the item set number, which is I2, that is 2. Next, I0 on small a, it makes a transition to I3. So whenever we are considering the terminals, we have to represent it as S3. So it is making a transition to I3, I0 on A. So I0 on A, we have to make it as S3. And I0 on B, it goes to I4. So mention it as S4 here. So next we have to consider I1. So if we see I1, there is no outgoing edges. So we go for I2. I2 on capital A, it goes to I5. So I2 row and capital A, it is represented as 5 because it is item set 5. So we are mentioning it as 5. And then I2 on small b, it goes to I4. So I2 on small b, it is I4 means S4. Then I2 on small a, it goes to I3. So I2 on small a, it is S3. Next, we have to consider the item set 3. So I3 on capital A, it goes to I6. So I3 on capital A, it will be 6. And then I3 on small a, it goes to I3. So it is I3 on small a, it is S3. And then I3 on small b, it goes to I4. So I3 on small b, it is S4. So next, if we consider I4, there is no outgoing edges, and in I5 also no outgoing edges, I6 also no outgoing edges. So we have constructed the shift operation. Next we have to consider the reduce operation. So consider for reduce operation, we have to consider the production which is ending with the dot. So consider each item set here. In item set I0, we don't have any production with ending with dot. So if we consider I1, we have S dash tends to S dot. So write it. So I1 item set is I1 and the production is S dash tends to S dot. So in I2 also no production ending with dot. In I3 also no production ending with dot. If we consider I4, it is A tends to B dot, and I5 we have S tends to AA dot, and then I6 we have A tends to AA dot. So thus we have written all the productions which ends with dot. So next thing is we have to find the follow. So follow of non-terminals, that is S and A. So for follow of S, always it is the starting symbol. So for start symbol we have to introduce the dollar for follow. So follow of S is dollar. So if we consider A, we have A here in 3 places. If we consider this A, since it is not coming at the end of the production, we have to find the first of the next symbol. So next symbol for this A is A. So we have to find first of A. So first of A is nothing but small a and small b. And in these cases we have A at the end. So in this case we have to find the follow of its left hand side. So follow of S is dollar. So follow of A will be A, B and dollar. Now consider 1 comma dollar is always accept, so we eliminate this production. So consider the item set 4, that is A tends to B dot. So what is the production number of this A tends to B dot? It is production number 3. So we have to find the follow of this LHS of the production. So that is follow of A is AB dollar. So in the item set 4, in the row I4, for AB and dollar, we have to write the production number of A tends to B dot. So the production number of A tends to B dot is 3. So near I4, under the column A, B and dollar, we write R3. Next we consider I5, S tends to AA dot. It is the production number 1. So here the left hand side is S. So we have to find the follow of S. Follow of S is dollar. So near I5 and dollar, we write the production number 1, that is R1. And next we consider I6. So its production number is 2. A tends to AA. So it is production number 2. So follow of A we have to find. So AB dollar. So in the item set 6, under AB dollar we have to write R2. So R2 in A, R2 in B and R2 in dollar. So thus we have constructed the parsing table. Next we have to parse the given input string using the parsing table constructed. So Consider the input string here. We have AB, AB. So for parsing the input string, we need three columns, that is stack, input string and action. In the stack, we initially will be having the item set 0, and in the input string, we'll have given input string along with the dollar, that is AB, AB. It ends with dollar. And for action, we have to consider the top of the stack and the first symbol in the input string and compare it in the table. So 0, comma A. So item set 0 on A, what is the action? We have S3. So mention S3 in action. So S means shift. So shift means we have to push the first symbol in the input onto the stack. So already we have 0 in the stack. So push A. After pushing the input symbol into the stack, we have to compare 0. That is, we have to write the number associated with the action. That is S3 means we have to consider S3 and add it into the stack after the A. Now, what is the remaining symbols in the input string? It is B, A, B, dollar. So, consider 3 and B in the table. So, 3 and B in the table is S4. So, the action is S4. Again, shift. So, we have to push the first symbol in the input onto the top of the stack. So, already we have 0, A3. So, push B. So, 0, A3, B. Along with B, we have to add the number of this action, that is 4. So, it is added. So, remaining is AB, dollar. Consider 4 and A. So 4 and A, it is R3, that is reduce operation. So in reduce operation, we have to consider the production number 3. R3 means production number 3, that is A tends to B. So till B, we have to reduce it to A. So how to reduce means we have to pop out the symbols from the stack. So how to pop out means we have to multiply the number of symbols in the right hand side to 2. So one right hand side RHS is having only one symbol, so 1 into 2 is 2. So we have to pop out 2 symbols from the stack, that is 1 and 2. Till B we have to pop out. So after popping, we have to introduce the variable A here. Instead of B and 4, we have to introduce A here. So 0, A3, A. So we have to, after writing A, we have to compare 3 and A in the table. So 3 and A in the table is 6. So introduce 6 into the stack. So next we have input string as AB dollar. So compare 6 and small a. So 6 and small a is R2. So R2 means production number 2, that is A tends to AA. So in the right hand side we have two symbols. So 2 into 2 we have to consider. So 2 into 2 is 4. So totally we have to pop out 4 symbols from the top of the stack. So 4 symbols means that is still small a we have to pop out. So 1, 2, 3 and 4 symbols we have to pop out, and we have to replace this with this capital A. So it can be written as 0 A. So 0 and A has to be checked into the table. So 0 on capital A, it is 2. So that's what 2 mentioned here. And we have AB dollar in the input string. So next consider 2 and small a. 2 and small a is S3. So shift means we have to push the input symbol into the stack. So push A onto the stack. So it is 0 A to A, and then we have to write this number 3 on the top of the stack. So remaining we have B dollar. So consider 3 and B. So 3 and B, it is S4. So S4 means shift, that is push symbols into the top of the stack. So B is pushed into the top of the stack, that is 0 A2 A3 B, and then we have to use this number 4, and remaining we have only dollar. So consider 4 and dollar. So 4 and dollar is R3. So R3 means A tends to B. So we have one symbol in the right hand side. So 1 into 2 is 2. So pop out 2 symbols from the top of the stack, that is B and 4 is popped out, and instead of that we have to replace with A. So 0 A2 A3 A, and then we have to consider 3 and A. So 3 and capital A is 6. So write 6 here, and remaining we have in the input dollar. Again consider 6 and dollar. So 6 and dollar is R2. So R2 is A tends to AA. So we have two symbols in the RHS. So 2 into 2 is 4. Pop out 4 symbols from the stack. So 1, 2, 3 and 4. Till A it is popped out, and instead of it replace A. So 0 A to A. So we have to consider 2 and A here. So 2 and capital A, it is 5. So write 5 here, and remaining we have dollar in the input, and 5 and dollar. So 5 and dollar is R1. So what is R1? S tends to AA. So your RHS contains 2 symbols, so 2 into 2 it is 4. Pop out 4 symbols from the top of the stack. So till A we have to pop out and we have to replace it with left hand side, that is S. So 0 S. So consider 0 and S. 0 and S is 1, so write 1. So dollar in the input symbol, and 1 comma dollar we have to compare. 1 comma dollar is accept. So thus we have parsed the input string successfully. So we have understood about the concept of SLR parser in this lecture. Thank you.